Before we can really define that probability or p-value, we need to look at the hypothesis test a little more closely. So a hypothesis test is designed to assess the strength of the evidence against the null hypothesis. So the fundamental step in this process and in our reasoning is the question, is the data surprising given the null hypothesis? So if we go back to that basketball free throws, is it surprising that I only made 44% of my free throws if I'm really a 75% free throw shooter? The answer to that is yeah, that is a really surprising result. So specifically what we're looking for here is we want to find the probability of getting the sample data we got or something even further out there or less likely given that the null hypothesis is true. So we're looking at that probability, and we're going to call that a p-value. And probabilities range in value from 0 to 1. The smaller that p-value or probability, the stronger the evidence against the null hypothesis. So if that p-value is small enough, it means it's very unlikely we'd observe the sample data we got if our null hypothesis was true. So that probability of making those free throws, 0.00017, that's so tiny. But that's the probability that I would have only made 44% of them if I'm really a 75% free throw shooter. So that probability is obviously very, very small. But what do we do if it's a little bit bigger than that? Is 23% small enough that we'd say the null hypothesis isn't true? Does it have to be something more like 5% or 1%? What is that cutoff value that tells us that, yeah, that's a really small probability and most likely our null hypothesis is not true? All right, so before I tell you how we're going to make that decision, I want to look at comparing a hypothesis test to a jury trial. So if we think about these two things being similar, our hypotheses in a jury trial, our null hypothesis is that the person is innocent. The alternative hypothesis is that they're guilty. The jury is going to listen to this testimony and look at the evidence from the initial standpoint that the defendant is innocent. They have to determine whether that evidence makes sense if the defendant is truly innocent. So let's say, for example, that our registrar, Laurel Becker, has been accused of stealing the Mad Jack statue from out in front of the administration building. If the only evidence we had was Laurel's car was parked there at the time of the disappearance, well, she works in that building. That's not really convincing evidence that she's the guilty person. If we had receipts that showed she'd bought tools and rented welding equipment and a lift and a truck, okay, well, then that's starting to look a little more suspicious because now she has the means to be able to get the Mad Jack statue off the pedestal. And then what if the lawyers presented evidence and we had pictures of the Mad Jack statue being in Laurel's backyard? Then that really looks like she's probably guilty, right? So there's kind of a spectrum of evidence. We're looking at that point beyond which it starts to be like, yeah, beyond a reasonable doubt, this is looking like you're guilty here. Okay, and so in statistics, we are going to replace that term reasonable doubt with something called a significance level alpha. So it's a probability percentage that if we get less than that, that's how we're going to say guilty versus not guilty. So one thing to keep in mind, and we'll get to this in another video in just a little bit, our conclusions from a jury trial are either guilty or not guilty. So we don't ever declare someone innocent. We're always talking in terms of that alternative hypothesis, guilty or not guilty. And we'll make that decision beyond a reasonable doubt if we're in a courtroom. And if we're in statistics, we're going to look at that as a significance level of alpha. So come back in the next video and we'll look at how to define that.